On a crystal clear night, were you to look up at the sky and gaze at the stars, you might see the tail of our home galaxy, the Milky Way, stretching out before you. But whether you can pick it up with the naked eye or not, and sometimes you can, we also know there's another bright object right next to the Milky Way, and that it will eventually cause us big problems. That object is Andromeda, the closest major galaxy to our own. And though for now it may seem like nothing more than an inconsequential streak across the sky, it is in fact speeding toward us at a rate of 70 miles per second. And one day, in the distant future, it will collide with the Milky Way. So how concerned should we be? Right now, as we live and breathe and watch YouTube videos all about it, not very. We are still dealing with truly epic time periods here, with a collision not set to happen for another 4.5 billion years or so. But also, this isn't new ground for our galaxy anyway, as the Milky Way already has a history of major collisions, meaning that many of the billions of stars that now reside within it aren't permanent residents. It's thought that in total, the Milky Way has been party to at least 10 collisions with neighboring galaxies over the course of its history. And according to one multi-authored August 2020 study, at least 5 of those were large-scale, involving at least 100 million stars. With each of these past events, then, our galaxy has grown. But can we expect more of the same going forwards? What, for example, is the collision between the Milky Way and Andromeda actually going to look like? Scientists have been able to learn much more about it thanks to a 2021 image obtained by the Hubble Space Telescope of the ARP-195 galaxy cluster, which is a galactic group located in the Lynx constellation some 760 million light-years away from Earth. ARP-195 is a cluster that NASA describes as being made up of 3 different galaxies in a 3-way tug-of-war. The Hubble image, further described by NASA as showing 3, quote, squabbling galactic siblings, shows how the galaxies are inescapably attracted to each other, gravitationally bound, and seemingly headed for impact. It's a cosmic episode of genuine chaos then, although there is still some structure to be found. Among the 3 galaxies in ARP-195, the largest galaxy is predictably shown to exert the greatest influence over the others, and it's therefore thought that it will come out on top. The shapes seen in the Hubble image, which is a whoosh of dust, gas, and bright light, look as though they should be random, but actually there's a reason why they are as they are. Ultimately, in this case, scientists expect the 3 individual galaxies to merge into one single galaxy, so that when astronomers of the future look in the direction of what is now ARP-195, it won't be immediately obvious to them that all of this has happened. So ARP-195's fate is now inevitable, but why should we care about it? One reason is that what's happening there provides an early glimpse into what will happen here, with the Milky Way and Andromeda, and one other galaxy, which we'll get to shortly. First, we need to fully chart the rise of Milkdromeda, the name that's already been given to the galaxy that will exist once the Milky Way and Andromeda meet. First things first, while there is some potential for all-out carnage, scientists don't believe that we'll see endless explosions amid literal collisions of stars and planets taking place. This is because space is just too big, and the sometimes light-years-wide gaps between the stars inside individual galaxies mean that even when those galaxies are crashing through one another, it's still very rare that any physical thing would smash together. What's much more likely is that most objects will just idly pass by one another. And indeed, it's been shown that galactic mergers can actually increase the rate at which new stars are created in the long term, rather than causing more stars than usual to crash, explode, and disappear. The collision will certainly redistribute the stars and planets, though, of both the Milky Way and Andromeda, with both galaxies losing their spiral shape in favor of an elliptical structure in Milkdromeda. This means stars and planets flying off into different orbits after billions of prior years undisturbed, as both structures try to make sense of their changing conditions of gravity. The fates of the supermassive black holes at the core of each galaxy are a little more difficult to map, although there are predictions for a binary structure at first, before an eventual colossal merger emitting a gravitational wave so strong that it will travel across the universe. An extremely bright quasar is then predicted to form, with an incredible mass billions of times greater than the Sun to anchor this new galaxy to the rest of the cosmos. The Milky Way is no more then, Andromeda is no more, and Milkdromeda is here. But what of Earth? And what of that third galaxy we mentioned before? Our planet could well be flung out into interstellar space, or it could remain unmoved. It's almost impossible to tell with certainty, although it's thought unlikely that it'll be outright destroyed. At least, not by the merger. What will almost certainly destroy Earth before any of the rest of this stuff happens is the Sun running to schedule and evolving into a red giant at roughly the same time. For this reason, any hypothetical human astronomers of the future will have had to have relocated to some other part of space. So really, our vantage point at the creation of Milkdromeda could be very different from what we have now. But finally, why again are scientists so interested in that recent image of the ARP 195 threefold cluster? It's because, ultimately, the fate of the Milky Way does involve a third galaxy too, the M33 or Triangulum galaxy. M33 is the third largest galaxy of the local group, and predictions for its fate have somewhat divided the scientific community. What currently seems most likely is that it won't be actively involved in the initial collision between the Milky Way and Andromeda, but that it will become involved at a later date. Once Milkdromeda is formed, it could be that M33 spends a few million years orbiting around it before eventually merging into it as well. So we could also pitch the Milky Way's position as a three-way tug-of-war. Kind of. It's just that as the third galaxy involved, M33 really has very little say in the matter. Nevertheless, astronomers can't yet rule out another possibility, that the Milky Way may collide with M33 before it collides with Andromeda, which is a scenario that maybe, when we think about it on Earth, feels like it shouldn't make much of a difference. But actually, on the grand and majestic scale of space, it would involve redirecting the future paths of whole worlds and entire planetary groups. It's little wonder then that any image showcasing anything that's even similar to what we're expecting from the Milky Way should cause scientists and astronomers to take note. For now, the pictures of ARP 195 act something like a guide, revealing to us just a tiny glimpse of what the future holds. And when you consider that all of this is but a warm-up act for another even further off time when Milkdromeda 2 will inevitably merge with other nearby galaxies, the sheer immensity of the universe as a whole comes into even sharper focus. There's just so much going on here, and there's seemingly no end to it. It's perhaps a little terrifying, but it's also pretty amazing.